Hello everyone, welcome to this video. In this video, we will discuss on LeetCode problem number 2197, which is replace non-coprime numbers in array. First, let's understand what are non-coprime numbers. So, non-coprime numbers are those numbers, let's suppose a comma b, which have the greatest common divisor greater than 1, right? Or what are coprime numbers, I can say. Two numbers a and b are co-prime number if the greatest common divisor of a and b is equals to 1, right? And let's understand it again. We have number 4 and 5. Does it have any common divisor? No. So the GCD of which is greatest common divisor of 4 and 5 is equals to 1, hence they are co-prime numbers. Whereas, let's look into 6 and 9. Does they have any common divisor? Yes, 3. The GCD, the greatest common divisor of 6 and 9 is 3, hence they are non-coprime numbers, right? Now let's go to the problem description again. We have given an array of integer nums. We need to perform the following operations. First, we will find two adjacent numbers which are non-coprime in nums array. If we don't find any such numbers, then we just simply stop the process there only. If not, if we find any non-coprime numbers, then we will delete those two adjacent numbers and replace them with their LCM value, which is least common multiple. Okay, we will repeat this process as long as we keep finding two adjacent non-coprime numbers in an array. One thing it needs to observe here is that replacing adjacent non-coprime numbers in any arbitrary order, I will repeat, any arbitrary order will lead to the same result. What does it mean here? So let's suppose we have a array like this, 4, 6, 8 or 12, right? Now 4 and 6 have a common divisor too, hence they are non-coprime numbers, right? 6 and 8 is also adjacent number and they also have a common divisor of 2 only. They are also non-coprime numbers. 8 and 12 also have a common divisor of 4. So they are also non-coprime numbers. Now, I can either pick first 6 and 8, or I can either pick 8 and 12, or 4 and 6. It doesn't matter. In what order, like which adjacent numbers I am processing first. The final array that we will have will always give the same result, irrespective of the order that we will pick, right? So I hope you get the idea that if it is not dependent on any order, then we will just simply start from leftmost position of the array, right? Let's understand how we solve this problem with this example. So we have this nums of array, which is this, right? So you get an idea that we will start from left and we will keep iterating, right? So let's suppose we have this result vector. Okay, we start from the first index. Here we only have a 6, so we just push 6 in the array. Then we go to the second index and then we push 4 in the array, right? Now we have two numbers in the array. So two adjacent number I would say in the array. So we will look whether they are non-coprime. So does 6 and 4 is non-coprime? Yes, 6 and 4 has a common divisor which is 2. So we will replace 6 comma 4 with LCM of 6 comma 4, which is equals to 12, right? So our resultant vector will be look like this. Earlier it was this, right? We are at this second index, okay? Now Again, we will check, are we able to do any operations on this resultant factor now? No. Why? We only have a one number. We at least need a two numbers, right, to perform the operation. So we will keep going on the next index. So now it is 3. So we will first push 3 into our resultant vector. Now we will check, there are two numbers in the resultant vector, right? So we will check that does 12 and 3 has any common divisor? Yes, 12 and 3 has a common divisor which is 3 only. So we will replace 12 comma 3 with LCM of 12 comma 3, which is equals to 12 only. So now our resultant vector will be 12 only, right? Again we will go to the next index now. We will go to 2. We push the 2 here. Right, now we will see, does the last two values from this resultant vector are non-coprime? Yes, 12 and 2 has a common divisor which is 2 only. So we will replace 12 comma 2 with LCM of 12 comma 2, which is equals to again 12. So our resultant vector again will be 12 only, right? Now we will go to next iteration, which is 7. So we will push first 7 here. We will check, 12 and 7, are they non-coprime? No, they don't have any common divisor which is greater than 1. So we will simply go to the next iteration. So we will go to 6 here, and we first pushed it in the resultant vector. Now again we will check the last two values of this resultant vector, which is 7 and 6. So are 7 and 6 are coprime? 7 and 6 are non-coprime, right? They have a common divisor which is 1 only, right? Sorry, 7 and 6 are coprime. They have a common divisor 1 only, right? So we will go to the next iteration. So we come at the last index, which is 2. So we push 2 again. Now we will check 6 and 2. So 6 and 2 are non-coprime. They have a common divisor of 2. So we will replace 6 comma 2 with LCM of 6 comma 2, which is 6 only. So our resultant vector will be now 12 comma 6 7 comma 6. Now we will check the last two values of this resultant vector again, which are 7 and 6. Now the 7 and 6 are non-coprimes. 7 and 6 are coprime number only, right? See, we will stop our processing here because we don't have any other index to go, and we don't find any coprime number. The last two values are also not coprime number only. So hence we will stop processing here. Hope you get this. So this is how similarly we will code here. Okay, you can try to perform this example number 2 by yourself before going to solution. So you will also get a more idea like how we are solving this, right? Now we need actually here two function. One is to get the greatest common divisor, and one other one is to get the LCM. I will not go into detail like how this is working. You can there are certain algorithms which is used to find this greatest common divisor, and LCM is nothing but simply we divide the one number with the common greatest common divisor of these two and then multiply with other number. That's how we will get the least common multiple, right? So I have also mentioned the time complexity here. The time complexity that this function is taking is nothing but O of log of minimum of A and B. You can check this online. There are multiple resources where you will able to understand how this function is working here, right? So I will not go into detail for this. Now let's come to this main function. So similarly, the how we perform the iteration here, we will do the same thing in the code as well. So we first create our resultant vector, right? We will start our loop from leftmost position. What we will do, we will first push this nums of I into our resultant vector, right? Then we will keep looking the last two values of the resultant vector, right? So while resultant dot size is greater than 2, so we will first fetch that last two value. So one is resultant back, then we will remove this value from the resultant vector. Again, we will fetch the second last value, and then we will remove this value as well from the resultant vector as of now. Now what we will do, we will first get the greatest common divisor, right, of these two values. So we will call this function to get the greatest common divisor. Now, if g is equals to 1, if the greatest common divisor is 1, that means these two numbers are coprime numbers, hence we will not do any operation here, and we just simply push these numbers again to our resultant vector. Now remember, when we are pushing the number, the last second number is b. So we will first push b and then a. This is a common mistake that generally people makes here. So first push B because B is the second last. B is the second last number, right? Last is A. So we will first push B and then A, right? If this A and B are non-coprime numbers, that means if they have a greatest common divisor which is greater than 1, right? So what we will do, we will replace A and B with their LCM value. So we will just simply get the LCM of A and B, and we will just simply push that LCM value in the resultant vector. And that's all. We will keep repeating this process until and unless the resultant size is greater than 2, and we keep finding the non-coprime numbers, right? So here in if condition, if we don't find any non-coprime like this A and B is coprime number, then we need to break as well, right? Similarly, what we do here, we calculate this 7 and 6, right? We find that these 7 and 6 are coprime numbers. So we just simply break and we go to the next iteration. It's not like we will check 12 and again, right? We just simply checking the last two values, right? So here we need to break as well. Now in the end, we will just return this result vector. Okay, let's run the test cases. Uh, Sorry, did I did something here? The expected. Sorry, it should be greater than equals to 2, right? Like many, at least we have two values. I just forgot to mention that equals to sign. Okay, now the test cases are accepted. Let's try to submit this. Okay, our solution is also accepted. Okay, that's how we solve this problem. Um, Hope we get this, and if yes, then please like and subscribe this video so that I can regularly upload such daily LeetCode problems for you. And I will also recommend to please solve these problems by yourself. Like video is just to get how we should solve this problem, But after looking into these videos, you should try yourself to solve such problems, right? It will boost your confidence only, right? And let's analyze the time complexity as well here. Sorry, I forgot to mention that. So here, right, I just mentioned that this GCD function it's taking log of minimum of a comma b, and then this iteration will take O of n only, right? And then we are calling this GCD function here. So the maximum complexity that it can have is O of n into log of n, where m is nothing but we can say the maximum number which will be called in this GCD function, right? So this is our time complexity, and space complexity will be of course O of n, which we use to store this resultant vector, right? I would not say this is extra time complexity because this is what we needed here, right? But still, yeah, the space complexity will be here, O of n. Okay, hope you like this video. Thank you.